you have any questions? Anything to talk about?
No, no. We can get right into it.
All right. So let's see what did we do last time. It's probably best to look at the diff where this is supposed to be trying to break up sequences.
Yeah.
And I guess, well, parameters is one. That's probably not the best one. And I can't really see any good one.
Yeah, I think we got to a point where it wasn't really clear that there was possibility for improvement.
Right.
The branching was so early on. In other words, just 3 big blobs, 2 big blobs.
So which one were we trying to look at as an example? Do you remember?
I think it was function parameters.
Oh, no, not function parameters. Function parameters are
function statements.
Maybe assignments.
Assignments.
Yeah, this one, if I comment out the format lines, the assignment.
If you do, I didn't realize the dunder would comment out the whole function like that.
Oh, it just changes the function name. I could just make something.
Oh, I see.
Okay, so this is on one line because it's well, on the outer level it's a sequence, and the code we had, of course this jumps around when it's line wrapped, the code we have will break it up. And I guess it doesn't really break it up correctly because this yield or star expressions should be its own element. This should be in parentheses. I guess. Assignment. Yeah, that should be in parentheses. It's og assign. Oh, that's before it. Yeah, so this is not entirely correct, and it also doesn't look very nice, I think. Right, so this is a choice that is looking pretty good.
Yeah.
But the sequences are not. So, 2 weeks ago, I think I had some idea for an algorithm for this, and of course now I need to remember how that was supposed to work. So let me go back to the previous version. That's more likely to be correct, at least. Correctly parenthesized. So this is assignment. And how do we break this big thing up?
By choice? Like a single target or a single subscript? Or...
Well, it is a big sequence, so it has a choice, then some some like tokens by themselves. Then this optional part.
Okay. And then another choice.
What is this choice doing here?
I don't know. Star targets.
This looks like. Oh, maybe on the outer level it's a choice. What did I comment out here? Oh, this is the formatting for the choice, which worked well. I wanted to comment out the formatting for sequence. Let's see how that changes things. Okay, that didn't change much. Alright, but okay, so this on the outer level is a choice. So you can have either this or that. So I guess we formatted this with this, and now we have this big sequence that needs to be split into individual lines. And this one is now an inner choice, then two individual tokens, and then this optional part. So how should this be broken up?
Well, let's see. Oh, that is a good question.
Well, I guess one thing we could do is just break it up like this. But then it's not very clear that this is one option in the choice and this is another one. Because the difference between those two would be whether we have this pipe here or not. I guess another option would be to break up this part.
Yeah, that's kind of what I was thinking. And then have the star targets and.
And then after the ending parentheses we have some other stuff. Do you think that's reasonable?
Yeah, so we would have the name. And then yeah, it seems like it would. Yeah, it seems like it would be like escalating complexity. You know, starting off with the simple and then getting it. It would sort of stack. It seems like it would stack up nicely.
Still don't know if I want to format it like this. And I guess we should also look at the grammar specification here.
Oh.
Well, that might be a nicer way to say this. Of course, this is before simplification, right? So the simplification went for this part, which is repeated here, and that got merged right into this. So here we have name, and here's a single target. Oh, look at how it's treated in the human written input. So there's a
Oh yeah.
closing parentheses at the end here. And I'm not sure that really helps that much. I'd probably rather have it here. But Guido will disagree with me.
Rita?
Guido van Rossum.
Oh, Guido, yes, Guido will disagree, yes, for sure.
Doesn't really like, or from what I've heard, doesn't really like the closing parentheses starting a line.
Okay.
But it's what Black does and what a lot of Python developers are used to by now.
Sure.
So probably want to go for this first. And once we broke up this, like the biggest element in that sequence, everything's now fitting on the line. So this is okay, and I guess our algorithm can move on to this part. And it's probably best to look at the largest element, like textually.
Yeah.
So we break that up into star targets or single target Auga sign. And we're done. Now, is this understandable? Would it be better with the closing parentheses like this? Of course, then we need to break this line up a bit more. But it's not really clear where this parenthesis ends.
Oh, I see. Yeah,
so it's probably better to have it like that. I'm not sure about indenting these pipes with one more space. I guess I personally would like this more.
That seems, yeah.
Which means we can get rid of one more space here.
Oh, that's much nicer.
Is it? We decided against that last time.
Oh, you mean versus having them in?
Yeah, like that.
Oh yeah, no. Sorry, indent is better. Indent is better.
Okay.
Yeah.
And that means we'll have two spaces here just to align these.
Yeah, I mean it doesn't affect the interpreter, right? I mean it doesn't.
No.
It's
okay.
Just for people. Yeah. Okay. Great.
So that was what the algorithm should do. Now I guess we should describe the algorithm, what it should do, right? So we're putting stuff in lines, and if the line is too long, then we look at the biggest element in that line and break it up. And what breaking it up will do is we'll get, so I guess it would be more simple like this. So we get an opening parenthesis, then we get some indented lines, and then we get a closing parenthesis, and the rest of, like the previous stuff from the line and last stuff from the line goes together with that parenthesis.
Yeah.
Right. Yeah, and then those indented lines are indented according to how far that opening parenthesis was. Which is interesting. I mean, if I go back here, so suppose we didn't want to break up this one, but this one. How would you break this one up? Should it be like this? Or should it go down here?
So we've got basically that previous choice is all what? Yeah, that actually does, because as you maybe put the yeah, exactly. That's
Yeah, this is better than having it all the way up here, right?
yes. Well, yeah, for sure. Yeah.
Okay, so the inner lines are indented just by one level, wherever this opening parenthesis is. So we basically split the line by putting whatever was before the thing we're splitting. Then we have the opening parenthesis, and I guess there needs to be some kind of symbol there. Then we have the inner lines, each of which is indented by an amount we know in advance. And each of these lines can be broken further. And then we have the ending parenthesis and whatever was on the rest of the line. Right? And if this or this would be too long, then we recursively try to break that up.
Yeah.
Oh. Okay, can I keep enough of that in my head to write that down as an algorithm?
Oh, God.
Yeah. Okay. I probably don't want to write it in terms of tuples of strings and lists and stuff like that. Probably want to like write a little class for it.
Oh, interesting. Okay.
Output line. Right.
Oh.
Make it a data class.
Oh, interesting.
Oh, maybe not. So the output line would have what? Would be initialized with nodes.
Nodes, yeah. Okay.
Right. And it would contain a list of things that could either be individual nodes or they could be separate symbols like this opening parentheses, or they could be well, that's probably it, right?
So you have to somehow describe them as a collection of these. In other words, a node is everything that's between the parentheses.
Well, a node is there's the AST node.
Oh,
Right.
That node. Okay, got it. Okay.
So this would either have like the full line of the node or full formatted representation,
Okay.
or it could have like a single symbol here.
Mm-hmm.
Oh. And I guess the output line should also have like the max length as a number.
Mm-hmm.
And then for the okay, well, let's do more classes here. Here's data class directly. Yeah. So this would have some kind of content, or so let's use either symbols or like representations of nodes. So this would be the node's format, the result of the format, or maybe the result of the format for precedence. I wonder how. Yeah, how should that work? Some bit more complication there. Maybe we should just add parentheses everywhere to start, and then see how that could be simplified.
Sure.
Which means that I probably don't want this as a data class. I'll just give it an init. So let's call format for precedence, which takes a parent precedence. I just use max here. So this should always give us parentheses, right? We have this max is the biggest number here, and if the precedence is lower than this parent precedence, then we get a parentheses if it's needed. Okay?
Yeah, fair enough.
Right. So now we do output node repr for each node in for each node in these nodes, and we have an output line. Okay.
Wow.
The magic will be and trying to split this output line in some way. So let's try splitting this. So splitting will go through all of the contents. It will look at the ones that are still output node wrappers. And it'll try to split the biggest one, right? We know the length of this content, so we'll sort them by the length of the content, and we'll try to split the biggest one. If that doesn't work, we try to split the next biggest one, and so on. Okay. All right. So how do we do this? So we'll need to remember the index of each node.
Okay. And that's why we have two.
Right. Yeah, let's call the contents parts. Okay. Okay, and we only include the part if it's this output node wrapper, because we can't really split output symbols. Okay, does that make sense?
Yeah.
Hopefully.
Part.
Then we sort this with a special key function. So
oh, that is kind of cool.
and we want the
This is really neat.
this, right? So we get the length, and then we put in a minus, or instead of minus we could put a reverse here, but I called it biggest content, so this key should sort by the length of the contents, biggest first. Okay.
Okay.
And then we go through them and we try. Oh, one more thing we should do in the beginning is well, sum everything up and see if we reached max length, right?
Okay.
So total length will be sum of the lengths of the parts. Right. Plus there are some spaces between them. And if that total length fits in our max length, then we don't need to do anything. Okay. Hopefully that works. So now we're in this loop. We're going by the length. Well, we have the biggest part here, and we need to somehow split that. So, I guess we could ask the node to split itself. Would that make sense?
Yeah, but and to split it along what's the set?
Well,
is there a particular separator? Oh no, just split lines. Oh, okay.
Split lines. And the split lines method would then need to return these output lines if it can be split.
Do we need like some sort of a condition there? So it's this for index part in contents by length. Split it.
Probably need to put in the.
Oh, I see. And then it does nothing if it's less than. Okay.
Max length. Right. And the split lines, then let's say the split lines can return either none if it couldn't split, or a triple. So if we didn't get it split, then we go on.
Okay.
Otherwise, we get opening, inner lines, and closing. Right, so opening would be like the opening parentheses, inner lines would be a list of the nested output lines, and closing would be the closing parentheses. Does that make sense?
Yeah. So split part is a split part is a list.
Split part would be a triple.
Triple. Oh.
The inner lines would be a list.
Ah, okay, okay.
Right.
So
and
okay.
Now we're done. So we just return. And we need to return a list of output lines here. And we need to create the output lines, but not from nodes, but from the output symbols as well. So let me rework this init a bit. So this init should get the parts directly, and I can write another constructor. So this would be a class method. And we call that class method with these parts and the max length. Right. And here the split. So we split one line into whatever came before this part. So that would be an output line consisting of this line's parts that came before this I. Right. Then we have the inner lines here. And then, wait, this output line also needs a symbol for the closing, for the opening parenthesis, right? And then after that we get a symbol for the closing parenthesis and the rest of the parts here. Does that look reasonable?
Wow.
This might be too much to write in one go. We'll probably need a bunch of debugging.
It's intricate. Yeah.
I don't know how to
But that's cool.
simplify it. Maybe there'll be some chance to make it simpler later. When this is working. Oh, it seems like the output line should have some kind of indent embedded in it. So these inner lines should be indented, and we're not really passing that indent along. So let's do that.
But is indent, is that an integer or a boolean?
Integer.
Like, it is an integer, so it's the number of spaces. Okay.
Yeah.
Okay.
So here we should probably go indent, do indent plus 1. Splitting the lines, and the output lines there should have one more indent, which means one more max length, one less max length, depending on how big the indent is. Probably want to indent like 2 spaces, right? Maybe the indent should be a string.
That could be. Yeah.
Yeah, it should, right?
Yeah, I think so.
Okay. Okay, so this does one split, right? And we want to call this split repeatedly.
Repeatedly. Okay.
Yeah. So we return this this list here.
Okay. Yeah.
And I guess if any of these resulting lines is too long, we want to split it again. And again, and again, and again. don't know if I want to do that here. Probably not. Or in, so this is basically split once. And anything that calls this will want to iterate on the splitting as long as this function returns a list rather than none. Right? Because if the line is good, this returns none. If the line is too long, it'll return a list. So let's do a proper recursive split. And what will that do? Now, as this won't be a method here, the recursive split will take a list of lines and basically go through them and split them. So
do we need a dog string?
Yeah. Or maybe a type annotation.
Oh, okay.
Something like that. Okay, so what do we do here? We will take the lines one by one, and we'll look at the next one in line, try to split it, and that split. We try to the split once. If the split once returns none, that means the line is good to go. We put it in the output. Yeah. If that returns a list, we put that list basically on the stack, right? So we do this to do stack, and we want to start with the first one, and let's have pop and append, which work on the end. So let's reverse this. And make it a list, right? Let's make the result a list as well. We probably could yield the lines from here, but it's probably better to put them in a list. And then while we have something to do, we take the first item from the to-do list and try to split it, right? And we need to remember what that line was. Now if this result is none, then we're done and we put this on the result. Otherwise, we take this result and we put it on the to-do lines. make sense?
Yeah, yeah.
So
It's awesome.
that's kind of recursive. Except it's not written in a recursive way, it's written with a stack. I remember my computer science classes where we wrote recursive algorithms in terms of iteration and vice versa.
Absolutely, yeah.
Yeah, the iterative ones always needed a stack with like pops and pushes. Alright, so now if we have a list of lines, we can split them. And that's great. So what do we do with this? I guess we go to some function somewhere that outputs the lines, and we write that. Generate rule lines here. So here, so we enumerate format lines. Okay, so that's where we do this. Let me split my view here so that I can see all the class names that I defined. So we split lines and the split line takes a list. So this will be a list with an output line where the parts will be well, we'll make the output line from nodes, and the node will be this one. There's a list of just one node. Max length, that's available space here. And indent, we don't need an indent when first creating it, so let's do that. Does that make sense?
Yeah, yeah.
And then we put the output lines here. And the line here will then, node is not defined, where typo here. Was thinking of music for some reason. This max length should be self max length, as the error message tells me. Result, none type has no attribute. I'm using the same variable name. Let's name this output. I guess this should have been a yield. Making a list, appending to it, and doing nothing else with it, and then returning. That could be a yield. Let's make it a yield. Alright, and now choice has no attribute split lines. Perfect. So that means so this is this one. So let's name it split into lines, maybe. just so it doesn't clash with the function name. So this is a method, this is a function. And now we add the split into lines method on, well, basically on all nodes, right? All of them will need some initial implementation.
Oh, I see. Right.
So this takes a max length and an indent, and initially the nodes cannot be split, so the base implementation will return none, right? And then the next error, hopefully we're doing test-driven development now, looking at the errors. So this line is now expected to be a string. So in order to treat it as a string, we can either convert it somehow or make it more string-like, which is probably better. So this length of the line is this total length here. Maybe we need to, well, maybe we want to cache those. So in order to put it in a string, we need to define this thunderstir. And since this output line is immutable, we probably want to cache the string representation. So I'll do that with a cached property. And I'll basically join the string representations of all the parts. Right? And then the length. Well, just be the length of this, right? And this can just be a property. Right, and I need to put in a len that will return the length. So this is a method, this is a property. Does that make sense? Maybe I can just keep the method here and do len self here.
Yeah, I don't really know what the property director decorator does.
Oh, okay. So it turns a method into an attribute.
Oh.
Right, so whenever I do self.string representation, there are no parentheses here. So to get this attribute, it'll call this function.
Oh,
right, so that's what property does. Cached property will also store the result, so it'll only compute it once.
Oh,
which
wow.
is pretty good because this can be recursive.
Wow. That's pretty cool.
Yeah, the cached property I think needs to be imported from functools though. Put it in here.
Wow.
Okay, then so this will be the length of this string representation. Missing a self on this line here, and now we're missing another self right next to it. Ooh, no errors except this is not good. Right, so the output node wrapper also will need a stir. Let me put this on the big view. So we have a stir here. We also need it on this and this, right? So to convert this to a string, we call we return the content on the same here.
Oh, I see. Right.
So what changed? Well, everything has parentheses around it, which is good. That is what I want right now. Just so I don't have to worry about the parentheses and stuff being confusing when they disappear. And I definitely want to worry about that later. So that's, looks like that's the only change. Oh, except things collapsed once again into one line. Now these choices don't get word wrapped, that's fine. This is looking good. We need to bring back the collapsing the choices, but otherwise this is good. Now, what's the next step here? I guess the next step would be to implement this split into lines for for the containers, for choice again. So we shouldn't be using this format lines function now. Let me comment it out. Yeah, this is never called now. I think there was another format lines for sequences, which is like entirely wrong. Let's remove that. And we, instead of format lines, we need to define the split into lines. Which will take self, the node, some max length, and some indent. Okay. And what will this do? It will do something like this one, right? So the initial part so a choice can always be split into lines, and it will yield it needs to yield an opening, inner lines, and closing. So the opening will be an opening parenthesis, but wrapped in some class we have here, like this output symbol. First time we use this output symbol, let's see how that goes. Then it will yield output lines with the individual choices, right? So output line from nodes, call them alts, for alt in self, right? And this will need a max length, and this will need an indent, and the indent needs to include this yeah, because this thing needs to be part of the indent, but it only needs to appear on the first line here. That'll be interesting. I still need to deal with that. Missing a comma here. Oh, the inner lines. No, this should just be a triple. So this can be a nested list. Put line. Missing some. Wait, where's this? Length. Oh. Parenthesis. Star returned non-string. Okay. That's interesting. So for output symbol, the content should be a string. Why is it not a string? Am I making output symbols? I'm wrapping output symbols in output symbols. I don't want that. Maybe I want to wrap things here. Okay, and now we see the choices get exploded, which is pretty good.
Oh wow, that's so cool.
Except we're not putting the indent in the stir here.
Oh, I see.
Now this is much cooler.
Wow, that is really cool.
Yeah. I think we got back where we were last time. Yeah. This is just
that's beautiful.
Adding the parentheses to stuff. Yeah. Sorry if you can hear the kid.
No, not at all. No.
Oh, good. Okay, this is looking good. One difference is that before we continued the line, with the first choice here, and in the new thing we have an empty, like an empty opening parenthesis when something is broken up into lines. And then it starts with this pipe. I think that's okay. It might look like, you know, we have an empty choice here, but that never really happens in the grammar. And another problem here will be that if this gets broken into individual lines, this pipe is part of the indent, so it'll get repeated. So this should really only appear on the first line. I'll need to solve that later, but this is good enough to go in Git, I would think.
Yeah, it's really nice.
And I guess I should also remove the old implementation while I'm at it. It did do some more stuff, but we'll remember to do that later. All right. Now, what do we do now? I guess we can try breaking up sequences. If we want to break up a sequence into lines, what will happen? Something happened.
Yeah. It didn't break.
Well, this is actually surprisingly good.
Oh.
So, let's look at the assignment again. It's very far from perfect, but we get this, right? The problem here is, as I said, these pipes should only appear on the first line of each choice. So that's probably the first thing we need to fix. I don't know where this came from. Oh, I know where that came from. This indent for the sequence should never have a pipe. So let's do that again. Right. So if it's a sequence, it should never have a pipe ever. So here, these should become spaces. That's probably the first thing to fix. And this is rather readable, I would say.
Yeah, I agree. I mean, honestly, yeah, that's really incredible.
So, what do we do here? The indent will be a little bit more complicated, because we need to do something special for the first line with the indent, and something different for the subsequent lines. Then we get this, and then I guess what we can do after that is sort of combine things if they like combine the first line of a broken up expression with like the opening parentheses for it.
Okay.
Well, maybe the.
Looks nice. Well, that scans well because the choice and then it's, you know, it seems like they're more clearly delineated, like the branching.
Huh. Would you rather have this than this? I guess it does scan better, doesn't it?
Yeah.
How's this though?
Yeah, that's okay.
This
maybe that
is like a redundant level of parentheses.
Yeah, it does feel that way. Because there's nothing in between. Yeah.
I wonder how to get rid of that. So these parentheses are around like this expression here.
Yeah.
That still might need some work. Maybe these parentheses. Yeah, I guess we need to insert parentheses depending on the like priority. This will still be complicated. Anyway, the indent thing is definitely the worst thing we have here. So, what do we do? We have like the first indent and subsequent indent.
First indent, next indent.
I guess that's it. Like.
Sure. Subsequent, sure, why not?
Running indent.
Running indent, yeah.
The problem is now this is a recursive thing and this needs to be everywhere.
Oh.
So I guess I'll make this optional at least. Or if running indent
that's cool.
is none, then it'll be the same. Otherwise, it'll be set to. Well, where's my keyboard skills? I didn't use this keyboard for a week, and I missed time. I think I've mistyped before as well. So, now things become more complicated because whenever I split stuff, so this output line should use the first indent. Oh, let's go by the errors, I guess. We get here. So split into lines needs to have both indents. Right, so self first indent and self running indent. Right. Then this output line will have the first indent here. Then it will have the inner lines. Oh no, this one will have the first indent. These will only need the running indent for everything. Because only this is the first line as far as we're concerned. Okay. Then in the string representation we need to use the first indent. And well, where's the next error? When we're splitting into lines, what are we splitting here? This is the choice. So first indent will be this, and running indent will be that. And then this is just, for both of the indents. Okay, did that fix stuff? Yes. Yeah, nice.
There, that's really good.
That's pretty neat.
That is beautiful.
Right. So what's next? I guess next we need to get rid of these redundant parentheses.
Those are like the first parentheses.
The parentheses here, and then there's one here.
Yeah.
Right, so we have oh, it's exactly the same as what I've written by hand. Nice. So this level of parentheses is redundant. This level of parentheses is redundant. How do we figure that out?
Well, it always be after a choice. So if there are like two parentheses after in the output line,
well, I guess we need to keep track of whether we need to add parentheses or not.
I see.
Which I guess would mean we need to keep track of the priority of the enclosing node. Yeah, I guess that's it. And I'll only add them if necessary. I think first thing to do is think we're hard coding too much in this split into lines.
Okay.
It's currently returning the triple with a symbol, then a list of lines, and then the ending symbol. And this should probably just return a list of lines. Maybe we like if the sequence didn't add any parentheses here, maybe this needs to be like an empty list. The one in choice needs to be a list of output symbols here, and that back in the this here, this opening will then be a list of parts. That get basically added to this new line. How will that work? Yeah, so we got rid of these parentheses. It's probably not okay to always get rid of them. We should take into account like the priority of the enclosing node.
Right. Okay.
We should use the same algorithm as for adding these. But another thing, I guess, is we need now to get rid of this indent here. Like here. If we don't add parentheses, then we don't add an indent either.
Oh.
Except now we're getting empty lines here. Don't want that. So
is it this output line? Oh. What's the plus inner lines?
star inner
Is there
lines. So it's
that's
includes
the thing.
this
Okay.
in the list.
I see. Yeah.
Well, I guess if we're omitting parentheses, then we need to both omit the parentheses and the indent. And and somehow combine. Well, not put an empty line here. Right. So let's try it like this. Bend. Then instead of star we do extend. And then we append the ending line. Okay. That should not change the result. Oh, the result has already changed because I removed this indent. That's fine. So I guess now if this output line would be empty, we just don't add it at all. It, right? No. no. Wrong. Oops. Yeah. Because this opening line has our first indent. Oh, everything else has the running indent. So I guess this is getting complicated, right? If we skip the opening line, we got rid of this first indent, and that first indent should go in the first one of these inner lines. Right? Right, something like this, but that's not really correct. I mean, it's correct here now, but these output lines are supposed to be immutable.
Oh boy.
what does that mean? Maybe the data structure needs to be recursive. So the parentheses. Let me.
Yeah. So like if it's like we start everything without a parentheses. No.
So when we
Okay.
break up some element, we add parentheses to the front, parentheses to the back, and we also add the indent to the lines here. When we don't add parentheses, we don't indent stuff.
Right.
Don't indent stuff either, except we need to indent stuff if we have a choice, if we're putting the pipes in there. So that probably means choices always need to have parentheses around them.
Right.
But if we break up sequences, then they don't. Let me. Yeah, I guess sequences never have to add parentheses. When breaking up choices, we always need to add parentheses. When breaking up sequences, I guess the sequence needs to decide whether it wants a parentheses or not, depending on what it's part of. Just remove these indents. I get empty lines, which I don't want. Okay, I guess now I'm thinking without saying anything. Maybe it's a good time to wrap it up for the day and sleep on this.
Sure. Yeah, yeah, I'm certainly ready to wrap it up. It's kind of intense.
It is, but I think maybe I need to rewrite this algorithm again. But I'm pretty happy with like the first draft here. Maybe I need to study again how black does things. Try to find it.
Yeah.
Find the relevant code in there.
Sure. Sure.
All right. So
Yeah.
thanks for your time today, and see you next week.
Oh no, thank you.